So, hello everyone. This is Cadet Baran Matthew, and today we are going to answer Great Circle Sailing. So, we are given the problem number 2. Find the Great Circle distance, initial and final course from 10 degrees 25 minutes south, 90 degrees and 12 minutes east to 39 degrees 27 minutes north and 55 degrees 10 minutes east. Find also the position of the vertex and the longitude in which the GC track crosses in the equator and the course then. So first, we need to input our given positions. So first, our latitude A, which is 10 degrees and 25 minutes south, and 90 degrees 12 minutes east, and latitude B, which is 39 degrees 27 minutes north and 55 degrees and 10 minutes east. So after we input our positions, so next we will find the Great Circle track. So latitude A will be probably located here. Latitude A, which is 10 degrees 25 minutes south, 90 degrees 12 minutes east, and our latitude B, which is the north, will be probably located here. It should be north 55 degrees and 10 minutes east. Then we will connect. So since we already had our we connected our latitude A to latitude B, so we will use the North Pole in order to determine our initial course and final course, and our equator is located here. So our equator is located here, so we should label it equator. Now, since we already have our equator, next is we need to find our d long, or the value of p. So in finding our d long, we need to use our longitude A and B. So since our longitude A and B has the same name, and it is written that if you have the same name, so we need to subtract it. So since it has the same name, which is east, so we need to subtract it. 90 degrees and 12 minutes subtracted by 55 degrees and 10 minutes. So we will get 35 degrees and 2 minutes as our d long, or the value of p. So since we already have our d long, so next is we need to get the distance between latitude A and latitude B. So in getting the distance, we need to use the cosine the cosine rule, which is the cos AB is equals to cos P, which is the D long, times cos latitude A times cos latitude B plus minus sine latitude A times sine latitude B. So since we already have our formula, so we need to input the values that we needed. Cos P, which is our D long here, so we need to substitute 35 degrees and 2 minutes times cos our latitude A, which is 10 degrees and 25 minutes times cos latitude B, which is 39 degrees and 27 minutes. And since to determine if it is add or subtract, so we need to look the names of our latitude A and B. If it has the same name, so we need to add, and since we have different names, so we need to minus sine latitude A, which is 10 degrees and 25 minutes, multiplied by sine latitude B, which is 39 degrees and 27 minutes. And to get our cos AB, so we need to input it in our calculator. So cos P, 35 degrees and 2 minutes, times cos 10 degrees and 25 minutes times cos 39 degrees and 27 minutes minus sine 10 degrees 25 minutes times sine 39 degrees 27 minutes. So we will get this number or answer, and to get our cos AB we need to inverse, so we need to shift cos and the answer to get our degrees. So we will get 59 degrees 32.26 minutes, and that would be the degrees from latitude A and latitude B. And to find the distance, so we just need to multiply it by 60. Multiply by 60, so we will get 30,000 distance. We will get 3,572, and we will round it off into 3 miles. So that would be our distance. So since we already have our distance, so next is we need to find our initial course. So in getting our initial course, so first is we need to input our given values. Our D long, which is needed in solving our initial course, which is 35 degrees and 2 minutes. And we need to use our latitude A, which is 10 degrees and 25 minutes south, and our latitude B, which is 39 degrees and 27 minutes north. So first we need to solve for our A, B, C. So our A course is, we need to use the formula of tangent latitude A over tangent B. So tan latitude A, which is 10 degrees and 25 minutes south, over tan P, which is 35 degrees and 2 minutes. So the value of our A, 10 degrees, 25 minutes south, and tan P, 35 degrees and 2 minutes, is 0.2622188,377. That would be north. Next is our course B, and we will use the formula tangent latitude B over sine P, and substitute tan latitude B, which is 39 degrees and 27 minutes north, and sine P, which is 35 degrees and 2 minutes. And the value of our P is tan 39 degrees and 27 minutes, and sine 35 degrees and 2 minutes is 1.433442403 north. And next is our C, which is A plus minus to B. So since our A and B has the same names, which is north, so we need to add. So A, which is this 0.2622188,377 north, plus B, which is this. So we already inputted in our calculator, so we need to add for A, which is 0.2622188,377, and we will get 1.695661,241 as our C. So we already have our A, B, and C. So in order to get our initial course, is we need to use the formula of tan AZ, and that is 1 over C times cos latitude A. So we have 1 over RC, which is 1.695661.241 north times cos latitude A. Our latitude A is 10 degrees and 25 minutes. So we will get, so since we already inputted our C, so we will directly type 1 over answer times cos our latitude A, which is 10 degrees and 25 minutes, and we will get our 0.5996228,698. So since tan is here, so we need to inverse it. So shift tan to inverse and the answer to get our final initial course. So our initial course would be 30 degrees and 56.87 minutes west and north. That would be our initial course. So since we already have our initial course, we need to find the true initial course. So in order to find our true initial course, we need to determine the location of our initial course. So since we have the direction of northwest, and northwest is we need to minus it into 360, so as shown above. So in order to get our true initial course, so 360, we need to minus it with 360 minus our initial course, and here we will get our initial course of 3 to 9 degrees and 3.13 minutes true. So that would be our true initial course. So we already have our true initial course. Next is we need to find our final course. Final course. So we need to input again the needed values, which is PRD long 35 degrees and 2 minutes, and our latitude A here will be using the latitude B. So the latitude B will become the latitude A in the final course, 39 degrees 27 minutes north, and the latitude B is the latitude A, so 10 degrees and 25 minutes south. So again, we will need to find our A, B, and C. So A, we need to use the same formula, latitude A over tan B, and tan latitude A will be 39 degrees and 27 minutes north over tan B, 35 degrees and 2 minutes. So our A is tan 39 degrees 27 minutes, tan 35 degrees and 2 minutes is 1.173728746 south. Next is our B. We will use the same formula, which is tan latitude B over sine P. That is tan 10 degrees 25 minutes over sine 35 degrees and 2 minutes. And our B is tan 10 degrees and 25 minutes over sine 35 degrees and 2 minutes. Degrees. So we have 0.3202406025 south. And next is our C, which is A plus minus B. So since our final course A and B has the same name, which is south, so we need to add A plus B. So our C is, so we need to add our A, which is 1.173728746. 173728746. So we will get the C of 1.493969,348. So that would be our C. So since we already have the final course A, B, and C, so we need to use the tan AZ to find the degrees of our final course. So 1 over C times cos latitude A. So 1 and the C, which is this, and multiplied by cos latitude A, which is 39 degrees 27 minutes north. So we will get, so we will input it 1 and our C times cos 39 degrees 27 minutes, and we will get this answer. And to finalize is we need to inverse tan, since we still have tan here. So to get our final degrees, we need to inverse it. So shift tan and the answer. So we will get our final degrees of 40 degrees and 55.20 minutes. That is southeast. Okay. So we already have the degrees And to find the true final course is we need to locate our final course, which is southeast. So southeast, as shown above, is we will subtract it with 180. So our final course, we will minus it with, subtract it with 180, and that will be our true final course. So 180 minus our AZ is 139 degrees and 4.8 minutes true. So that would be our true final course. So therefore our final or our initial course is north 30 degrees 56.87 minutes west, or 329 degrees degrees and 3:13 minutes true. And our final course is south 40 degrees and 55.20 minutes east, or 139 degrees 4.8 minutes true. So that's it. We already have our initial course and our final course. So since we already have our initial course and final course, so next is we need to find our vertex. So in finding the vertex, we need to use the Napier's rule. So in the Napier's rule, so we also need to use the Napier circle shown. And so in solving the Napier circle, so we need to use our latitude A, or in our initial course, which is 30 degrees and 56.87 minutes. And in as shown and the Napier circle, we need to find our PA. So in finding our PA is we need to use 90 minus our latitude A, which is 10 degrees and 25 minutes. So 90 degrees minus our latitude A, which is 10 degrees and 25 minutes. So we will get the PA of 79 degrees and 35 minutes. And lastly is we need to use our latitude A, which is the 10 degrees and 25 minutes. So now we need to use the sine rule to get our latitude and the longitude of our vertex. So sine PV is cos 90 minus A times cos 90 minus PA times sine 90 minus PA equals to tangent 90 minus A times tangent 90 minus P. So first is we need to get our latitude of the vertex. So in getting the latitude of the vertex, we need to derive this formula. So we will get cos latitude vertex is equals to sine A times cos latitude A. So we need to substitute sine A, which is 30 degrees and 56.87 minutes, times cos latitude A, which is 10 degrees and 25 minutes. So we need to input it in our calculator. Sine 30 degrees 56.87 minutes times cos 10 degrees and 25 minutes, and we will get this value. And since it has cos here, so we need to inverse cos, answer, and we will get this degree. So this would be the latitude of our vertex, which is 59 degrees and 37 minutes north. So that would be the latitude of our vertex. Next is we need to get the d-long of our latitude A to the vertex. So we need to derive this formula. So we got tan P, which is the d-long, cotangent A times secant PA. So we have cotangent A, which is 30 degrees 56.87 minutes times secant PA, which is 79 degrees and 35 minutes. So in order to get the cotangent and the secant is we need to reverse it. So we will have this solution 1 over, since the opposite of the cotangent is tan, so we need to use tan 30 degrees and 56.87 minutes, 87 minutes, that's 87, and times the opposite of secant is cos 79 degrees and 35 minutes. Let's see. So we will get that value, and since we still have tan here, so we need to inverse it. Inverse tan, the answer, and that will be our D long, or the P of the D long from our latitude A to our vertex. So that is 83 degrees and 48.74 minutes. So since we already have our P, or the D long, next is we need to find the longitude of our vertex. So in finding the longitude of our vertex, we just need to input our P, which is the D long from latitude A to our vertex, which is 83 degrees and 48.74 minutes, and our latitude of our vertex, which is 59. Oh, I mean not the latitude of our vertex, but the longitude A. Longitude A, that is 90 degrees here. Longitude A, which is 90 degrees. Degrees and 12 minutes east. So since it has different names, so we need to subtract it. So 83 degrees 48.74 minutes minus 90 degrees and 12 minutes. So we will get the longitude of our vertex, which is 6 degrees and 23.26 minutes west. So the final position of our vertex is 59 degrees and 37 minutes north and 006 degrees 23.26 minutes west. So that is the final position of our vertex. So since we already have the final position of our vertex, which is the latitude and the longitude, so next is to find the GC track that crosses the equator. So this is when GC track crosses equator. So as we know that longitude in which GC crosses equator is equals to 90 degrees D long from the longitude of vertex. So longitude, so we have the longitude of the vertex, which is 5 degrees 59.30 minutes west, and the D long from V to N, which is 90 degrees 00 minutes. So since it has different signs, so we need to minus 5 degrees 0.59, no, 5 degrees and 59.30 minutes minus 90 degrees is equals to 84 degrees and 0.70 minutes east. So this would be the longitude at the equator. And so the course after crossing the equator is equals to the latitude of vertex, and that is north 30 degrees and 23 minutes west. So let's plot the vertex, or the position of our vertex, and the longitude of the equator. So since our latitude A is smaller, or has a smaller value over latitude B, so it is said that when latitude B is bigger than latitude A, so the vertex shall be after B. So our vertex will be located here. Our vertex, and the position of our vertex is 59 degrees 37 minutes north and 6 degrees 23.26 west. So, and lastly, the longitude of our equator is probably here, and that would be labeled as N, and that would be our final great circle track. So to finalize our answers, so we already have the D long, the distance in miles, the initial course, the initial true course, the final course, and the final true course, the latitude and the longitude of our vertex, and the longitude at the equator. So that would be all for today, guys, and I hope you learned a lot. So once again, this is Cadet Baran Matthew. See you next time.